Okay, so I'll just go over this really quick again. We're going to break the original fraction down into partial fractions. And what we want to do is we want to look at the factors of the denominator. Since it's already factored, we're going to write out every possible scenario. So we've got an x minus 1 squared, and then we have just an x minus 1. Now, the interesting piece that we have to remember is whatever's inside of the parentheses kind of tells us what we're looking at. So we have linear pieces inside of that parenthesis. So what I want to do is my numerator is always 1 degree less. Well, since this is x to the first power, then I'm going to write a, and you could do this, and I notice I'm not going to, but this is x to the 0 power, so I'm going to take 1 away, so I'm 1 degree less. Well, anything to the 0 power is 1, so we're just going to put the a on top. And same thing here, this is x minus 1, that's linear, so then we're just going to have the b on top. All right, so now, instead of doing all this work, we're looking for the common denominator out of all these, and the common denominator is always going to be the factored form of the original denominator. Well, what we're going to do then is we're going to multiply every single piece by that denominator. All right, and then we're going to play that game of just kind of reducing things out. Well, in this case, the x minus 1 squared, those reduce out, and I'm left with 2x plus 3. And then here we get the x minus 1 squareds cancel out, so I'm left with a. And now this is the tricky part. I only have one factor of x minus 1, so that's going to cross off with one of the squared pieces. So what's left over is a b times x minus 1. We cleared the denominators out, so they're gone, which means all we're left with are the numerators and any multiplication pieces of that. So now we'll just simplify. So I'm going to distribute the b to both terms. And then our goal is to think, okay, well, how did I get the original numerator here, the 2x plus 3? How did that come up? Well, how did I get a 2x? The 2x had to come from the terms that have an x put together. And then how did I get the plus 3? Well, the plus 3 had to come from the coefficients, or excuse me, the constant terms, so the a and the b. So notice every single value is accounted for. And then what I'm going to do is just kind of write this out. All right, well, how did I get the 2x? The 2x was really made up of, and I like to do this, there is no a term that has an x. So I'm going to say 0ax plus a bx. And you can put a 1 in front if you want, because there is a 1 here. And then how did I get the 3? Well, the 3 was made up of 1a minus 1b. And if you like the highlighting piece, you can see where they came from. The 2x, the bx, and then the 0, I added that in there. That's kind of like a placeholder. The 0 cancels it out, but it just keeps the position or the place open. And then the 3, the 1a, and the minus 1b. Now, I think it's important to really, and I didn't do this on this one, to write this 2x and the 3 over on this side. And the reason why is because my whole goal now is I've got a's and b's together. I don't know what they are. Those are the unknown items. And I've got two equations and two unknowns. And the easiest way for us to solve this is with matrices. So then we're going to take the numbers in front. Right? Those are the coefficients. The 0, the 1, and the 2. So 0, 1, and 2. And we always have to put kind of the numerator items are on the right-hand side. Those are your numbers. And hopefully you guys are well practiced in this, but the first item is A, the second item is B, and then that's your number. All right, and then the next part is the coefficients of the A and the B, so I got 1, and notice it's a -1, and then I've got the 3. So we took the expanded form of the numerators once we cleared the denominators, and then we looked at what gave us the x values, what gave us the constant term, and we turned that into a matrix. Now that you have that matrix, it's all technology, right? We're going to do reduced row echelon form in your calculator. So I'm going to pull up Desmos here. You just do desmos.com, math tools, graphing or matrix calculator, and then I want the new matrix, and it has 2 rows and 3 columns. And we're just going to type in exactly what our matrix was. And notice that's called matrix A. And then reduced row echelon form of A. That's where the RREF comes from. And then it actually already calculates it, and there's my answer. So I'm going to do a screenshot of this so you guys can just see how and where it came from. And then again, remember the order that it's written in: 1, 0, 5, 0, 1, 2. That tells me what A is, what B is, and then what numbers they're equal to. And some people like to draw the dotted line separating the last column. That tells them that, okay, 1A is equal to the number 5, and 1B is equal to 2. Now we got to be careful, right? If, let's say this was a homework problem and I stop right here, I'm not done. I found out what A and B are, but I didn't break this down into the partial fractions. So that's where you take your final answer. We know what A is. We know what B is. And they're going to go over the original denominators that we used to set up the problem. All right, so nothing super crazy there. The only new part was how we dealt with this x minus 1 squared and how we wrote that out. Other than that, this whole process is what we did on Monday and what we had you do on Wednesday yesterday. If you didn't do the work from yesterday yet, I highly recommend doing that because that's going to give you a lot of feedback on how this works. Okay, I do want to make one little note, and I'm going to change this really quick, but don't write my changes. What if A was 1/5 instead of just 5? Right? How would we change that? Well, instead of putting the 5 up here, we don't like to write it as an improper fraction, a fraction over a fraction. So writing it as 1/5 like this doesn't really work. So what we're going to do is we're going to say, well, wait a minute, 1 is in the numerator and 5 is in the denominator, so it becomes 1/5, and that's still the same A value, 1/5. We would just rewrite it with 1 on top and 5 on the bottom. And then the other thing, and I'm not great at this, so let me just show you quick. What if I called B -1/2? So the 1 would stay on top, the 2 would be on bottom as 1/2. But then you could put the negative here, and I tend to do that a lot. However, instead of writing the negative up here, you can get rid of the original plus and make that negative. So just in case you notice that in some problems, that's what could happen, and the negative goes out in front. All right, so those are just some hypothetical, be careful pieces. I'm going to fix this so it actually is the right answer again. And what did I have? 5, A was 5, and B was 2. So 5, it was positive 2. Okay, we just got a couple more to look at. And again, my goal today is show you some of the trickier ones that you want to be aware of. This one is called task card 7. So it's the problem number 7 on that task card that we're going to look at. And our goal is, again, to break down the fraction into partial fractions. So how did this become, how was it originally written when it was the addition or subtraction of multiple factors? Now you'll notice the bottom, it's a little different again. We have an x squared and we have an x minus 1. So it's completely factored already for us, which is nice. We don't have to factor it anymore. Right? So, but here's the tricky spot. What could the potential denominators be that gave me this answer? Well, I could just have the x squared. That could be a possible answer. Or some people are saying, well, wait a minute, couldn't you break this down into an x and an x? And you're right. So that means that I could have another x as a factor. Now, I don't have to write 2 of them. The reason why I'm not writing 2 is because that's kind of redundant. So think of it this way. If you have an x squared, that has to be a potential denominator. And then we're just going to take one less of that. Now, what if it was, don't write this part, but what if it was x to the third? Well, then I would have to have an x to the third. I would have to have an x to the second, and I would have to have an x to the first. So that's just, you're going to basically take every potential factor of whatever that piece is. Okay, well, what about the next part? X minus 1 is factored, so that also has to be as part of the denominator. Now, we want to look at this very carefully. Here we've got a linear function. So this is going to have, I got to go in order. So let's look at this. This one is quadratic, right? So I have to have 1 degree less than this. So I'm going to do ax to the first power, but then I also have to have a constant term with it. So this will have an ax plus b. And then here, the bottom part is linear. So this is x to the first power, so that's just going to have a constant term, but we have to go a, b, c. And since this part is linear, it's just going to have 1 degree less, which is d. Right? And that's where it gets tricky. This is the part, we're not going to do a lot with these, but it's just kind of recognizing where they come from. Okay, so now that I have my denominator split up, all the potential denominators that gave me the original denominator, I need to clear the denominators. So I'm going to times every single piece by what the original denominator was. Okay, so now when you become really skilled at this, you don't have to show this work in blue. If you know what's going to cross out, like here, you know you're going to have an x squared and the x minus 1. Those are going to go away. And then you're left with just the x minus 2. And then over here, if I have an x squared, well, that's going to go away. And you're going to be left with, now this is important, ax plus b times x minus 1. Notice how that is a binomial times a binomial. We're going to have to expand that and FOIL out. All right. And then we've got, now again, this is kind of interesting as well. I'm going to try to do different colors here. So notice I've got an x right here on bottom, and that's going to cross out not with this x, because this x is protected by the parentheses, but instead of an x squared, I'm going to get rid of the squared and say I have 1x left over, and that's going to get rid of the bottom. So then what do I have? I have c times one of the x's times x minus 1. All right. And then over here, we've got the x minus 1 goes away. So then I have d times x squared. So now this can be kind of confusing. So we want to just use and rely on our algebra skills. We're going to expand out, and that's why I did them in separate colors. I'm going to do the red part first, and this is FOIL. Now, hopefully, you don't need to show a lot of work for that piece. Right? You don't even have to draw the arrows, but ax times x is ax squared. And then ax times negative 1. And I'm going to times b by x. And b by negative 1. So we just FOILed that. The orange part, now keep in mind, this is c times x, so you could just write it as cx, and that's going to be distributed into the other two terms. So cx times x is cx squared. Cx times negative 1 is negative cx. And then d times x squared is just d x squared. All right. Now there's one little tricky piece here, as if this wasn't tricky enough. Once you expand everything out, notice how I have x squareds here. That's my highest degree, but the original numerator didn't have an x squared. Well, what I want to do is I want to put another place value in there. So I'm thinking that over here, this had a 0x squared, and that just makes everything make sense. So now what we're going to do is that same thing we did on the other one, except for now I'm going to focus on the x squared pieces. Now you notice the b part doesn't have an x squared. So I have to put a place value in that, and that has to equal the place value x squared, which has a 0 in front over here. Okay, so I'm going to take the, and once you get really good at this, you can actually skip this step and just write the matrix, but it's tricky. So I'm going to start with ax squared. Now notice I don't have a b, so I'm going to put 0 bx squared. That 0 is going to basically reduce that out so it doesn't affect it, but it's a placeholder. And then I've got 1 cx squared and 1 dx squared. And then that's going to equal, now notice instead of writing the 0x squared on this side, I'm going to put it over here just so then my matrix is set up when I want to actually draw this out, I'll have everything all set up perfectly. All right, so now we're going to deal with the x terms, and we want to go in order. So let's deal with the minus ax. That's going to be the next thing. And then I've got a positive bx, and I have a minus cx. But notice I don't have a dx. So I'm going to have to put a 0 dx in there as a placeholder. And then all of that should add up to give me whatever the original numerator was and for the x's. So Let's start with negative, and you can always put a 1 in front if you want. If you want to call it negative 1ax plus 1bx. And then notice there isn't, oh, there is a c, minus 1cx, but there isn't a dx. I'm going to put 0 dx, and then that has to equal the positive 1x. I want to make that red. All right. So then the last one is how did we get the answer of negative 2? Well, we added up any constant terms which doesn't have an x. So that's the minus b. And notice minus b is the only one, which actually, if you think of how this is going to be solved, that tells you one of the answers right away. And I'll point that out. So I do want to put this in order. I don't have just an a, so I'm going to put 0a. I do have a minus b, so I'll call that minus 1b. And instead of a plus here, you could just put minus. It doesn't matter. Plus a negative or just minus. I don't have any c values, and I don't have any d values. And all of that tells me it has to equal negative 2. So notice how this is basically set up in our matrix. Now we're just going to take the coefficients, the numbers in front. So I'm looking at the 1, the 0, the 1, the 1, and then the answer of 0. So for my x squareds, I have a 1, a 0, 1, 1, and then a 0. Some students like to write A, B, C, D, and then my answer or the number. All right, and then do the same thing with the x's. We've got a negative 1, a negative 1, a 0, and the answer of 1. Last one. All right, I want to point one thing out here to you all. When you have a row that's all zeros except for 1, notice what this is saying. And you don't have to write this, but it says negative 1 b is equal to negative 2. Well, if I divide by negative 1, b has to be equal to 2. So I actually know one of my answers very quickly because of how friendly this last row was in the matrix. All right. And then if you really wanted to, you could plug that in and do some substitution. You could solve this by hand. It's not as intimidating as we might think, but we are not spending time on that part. So now grab your Desmos calculator, and we're going to create a new matrix. I just like to clear everything. New matrix that is 3 rows by 5 columns. And then I always kind of just do a quick visual double check when you're typing it in, especially if it's a quiz or a test. You just want to make sure that everything's typed in exactly the way it is here, because if not, then you know you won't get the right answer. And then reduced row echelon form of matrix A. Oh, I think I made a mistake somewhere. I'm going to double check something to see. I'll show you where and why I think I made a mistake in a second. Um, so this is a good hint, and I'm glad this happened. Um, as annoying as this is going to be, um, I want to show you this because this happens every so often. Notice how I know I made a mistake. And I think that's important for you guys to see. I wish I could say I did this on purpose, but I definitely did not. Look at my answer. It should say A is equal to 1, but it doesn't. It says A plus C is equal to 1. And then it tells me what B is. Well, notice that's the correct B. And then it tells me what D is. But I have to have that identity matrix. I can't have a 1, 0, 1, 0. So that means I made a mistake. And I think I found my mistake right here. And this catches me every so often. I get caught up. This should actually just be an A. I accidentally put an extra factor in here. So we're not going to redo this problem because the next problem actually has that, it has this information on it. But here's what I should have done. Okay. So when we wrote our factors, the factors are correct. This is an x squared, this is an x, and this is an x minus 1. And this is the part that I got caught up on. So notice these were linear here, right? Linear, linear. But if I put parentheses around it, what's on the innermost part is linear. If it looked like this, then this part would be quadratic. And since it was just a single x right here, I should have only put an A. And that definitely changes the amount of work that I had to do here. So, like I said, that one was my mistake. I don't know why I wrote that when I did, but every so often you run into a problem like this. And I think this might be more valuable to see an error so you can identify it and then go back and say, oh, shoot, you know what? I did make a mistake right here. Okay. So hopefully that wasn't too painful. Now here's the nice thing. This work that we did here is still valuable because it's going to show up in the next example right here. All right, so this one is task card 9. And this is the last one that I'm going to have you guys write down. We've got one more that I'm going to show you. Yeah, but we're not going to go into having you write that one down. But definitely write this one down. And you'll notice this one's a little bit different. Okay, this one ends up having an x to the 4th minus 1. So we have to factor the bottom here. Why don't you do that right now? As you're writing it down, can you factor this bottom completely into perfect factors? All right, so we're thinking, how did I get x to the fourth minus 1? Well, x to the fourth can be made up of x squared times x squared. And then the only reason why I'm able to do this is because of the minus 1. If it was other numbers, it wouldn't work that well. But what are the factors of -1 that add up to give me 0? That's -1 and +1. But then when you look at that, you actually have another perfect square. This is the difference of squares. So this part right here, I'm going to do it in a separate color. This part right here can actually be broken down to x plus 1 times x minus 1. But notice this part right here cannot because of the addition. There are no factors of +1 that add up to give me 0. All right. So here's the part we want to set up. We factored this completely. This is my least common multiple that I'm going to end up timesing everything by. And when you look at the bottom, we get the x plus 1. That is one of the potential factors. And then I've got an x minus 1. That's another potential factor for the bottom, or a denominator. And then I've got the x squared plus 1. Now notice, this is to the first power, so there's only one of them. And now I'm looking inside of the parentheses. X plus 1 is linear. X minus 1 is linear. So we're going to take one less, which is just a coefficient. There's no x's here. But then inside of here, because of the plus 1, and this is where I made that error on the last example, this x squared plus 1 is quadratic. And it's the one that makes it quadratic, because out here, this is to the first power. So now I'm going to go a, b, c, x plus b. Okay. Now, here's the part that I'm going to see if we can skip some work. And let me, if this isn't friendly, let me know and I can write out the work. But what am I going to do? I'm going to take this factored form of the denominator, and I'm going to it's like writing that for each one of these, right? Instead of rewriting this, that's the spot where it would go. So instead of doing that, don't we know that x to the fourth, if I write this and multiply it by the numerator, all of these are going to cross out with what would be here, and the only thing that's left is the 2x. All right, and then if I write this whole least common multiple up here, what's going to reduce out? And x plus 1 is going to reduce out, and what's left over are just these two pieces. So I'm going to have the a value multiplied by x minus 1, x squared plus 1. All right. Well then, what if I rewrite the entire least common multiple, the denominator, right up here, and what's going to reduce out? The x minus 1 is going to go away with this x minus 1. So then I've got the x plus 1 times the x squared plus 1. But don't forget the b. All right, and then for the last one, if I wrote it, this whole thing up here, now keep in mind this is going to be multiplied by the cx plus d. So I'm going to put that in parentheses right away. And then what's going to reduce out is the x squared plus 1. So that's going to go away, and all that's left over is x plus 1 times x minus 1. Now this looks like a lot of algebra, and you're right, it is. There are things you could do to simplify your life a little bit. I don't really care how you approach this, as long as you correctly simplify each one out. The only hint I'm going to give you is right here. Don't we know that, and I'm going to write it above here, x plus 1 times x minus 1 is really going to give me the x squared minus 1. So instead of trying to FOIL this out and reducing terms, you know that this part is going to really be x squared minus 1, which you could have wrote that right away, and then I just have to FOIL here. If you want, you could distribute the a first just to this term, and then take this answer times the next one. Or some people just like to FOIL the x's first and then multiply everything by a. I don't care how you do it, but I want you to take some time right now and I want you to expand all of these out. And then if you feel comfortable, see if you can go all the way and solve it. The only hint I'm going to give you is you are going to have to add extra terms. At some point, I believe we're going to have an x to the third as our highest degree. So I know I'm going to have an x to the third spacer. I'm going to have an x squared spacer. And then there's the 2x, and there's even a constant spacer. So since all this is equal to 2x, I'm just going to put these spacers in between here. And I want you to work through and see if you can solve this. Okay, so let's just kind of talk through this. You may or may not be in the same spot. I tried to use a highlighter to show you kind of everything and how it works, but you can see it's definitely a lot of extra steps here. So we distributed or FOILed the first binomials, then I distributed a, and I have all the terms that have the a in it. And then I did the same thing with b. I FOILed the two binomials, then I times by b, and that gave me all the terms with b in it. And then I did the same thing, but this one is cx plus d, so I had to FOIL these two pieces, and then I have the c terms and the d terms. And then I noticed that there were some fillers, so you don't have to write the 0x to the third, 0x squared, or the 0. I did that just so we could see where the answers came from. And then we're going to write every term that has an x to the third, but notice the ones that aren't highlighted are my fillers, my space fillers, because there wasn't a 0 dx to the third, so I just put that in. And then there actually wasn't even a 0x to the third as an answer, and I put that in as well. And then we did the same thing with the x squared terms, with the x terms, and then the constant terms. And notice there wasn't a c value, so I put 0 times c. But that all is just so we can get our correct matrix. Now, if you are really good, you could probably skip this step, but there's a lot of errors that students make. In this, like I don't know if you saw me, I accidentally forgot a negative here when I distributed, and I caught it later on. But if you miss that one small negative, everything else isn't going to work, which can be very frustrating when you're doing a problem like this. So now we're going to take all the coefficients, and those are the numbers in front of all the terms. So I've got 1ax to the third, 1bx to the third, 1cx to the third, 0 dx to the third, and that has to equal 0. I'm actually going to put the numbers first, so then I don't have to keep switching my pen. And then we're going to do the same thing with the x squareds. I have a negative 1a, positive b, a 0c, and a 1 for the d. And then same thing here, 1, 1, negative 1, 0. Negative 1, 1, 0, negative 1. And now let's just grab our handy dandy Desmos. New matrix. This time it's 4 rows by 5 columns. And I always just double check that I typed everything in correctly. That looks good. And then we're going to do reduce row echelon form. Now this is, I'm glad this one popped up the way it did. If you notice, it gives us decimals. And we don't want decimals as our answer, so all you have to do is click the convert to fraction, and it'll automatically take those decimals and convert them. And then notice it's the identity matrix, which is a good sign. That means I didn't make any errors. And then we can use the information. A is equal to 1/2. B is also equal to 1/2. 1C is equal to -1, and D is equal to 0.
Would we have to put the answers back into the equation?
Yes.
Or can we just leave it like that?
Nope, great question. So notice, this just tells me the answers to A, B, and C, but it actually doesn't decompose this fraction, and that's our whole goal. I'm going to just bring this down. Our whole goal is to take this fraction right here and rewrite it as a new fraction. And these are not new fractions, these are new numerators. So let's see if I can do this so I can still see what this was our original denominators up here. So what you definitely have to do then is you have to take your answer and you have to take it under each of these new numerators. And then you have to write the A and B in the right spots. Now, remember, this 1/2, the 1 is in the numerator, but the 2 is in the denominator. So I'm going to put that 2 right out in front in the bottom. Same thing with where the B was. And then the C value was -1. And I'll jump up really quick to show you. Remember, this was -1C. So I'll have a -1x plus 0. So we technically don't even need to write that plus 0 in. I would leave it off, but this has to be your final answer because it is the fractions that added up to that gave me the original given fraction, right? If you just stop right here, then you're not done. You didn't break the fraction up. And that's what decomposing means, is it's taking the original fraction and breaking it down into the sum or the subtraction of the fractions. There's one thing that we could have done. Notice how this is a -1. So instead of putting a plus here, I could get rid of that negative up here and just call this subtraction, and that would do the same thing. Okay, we're not going to write this last one. I just want to show it to you quick, and I'm not even going to go all the way through and solve it because it's pretty lengthy. I just want you to see it so you're aware of it. Okay? And I will be posting these notes on Schoology, so if you missed something or let's say you didn't get the same answer, you can go back and look. Just don't do it for this example that I screwed up on, but I actually think that error was more valuable than going through it. All right. I'll just give you a big hint, you probably won't want to do task number 5. I hate to say it, but this is tricky. And the only reason why it's tricky is right here. This, if you remember back from Algebra 2, and again, you don't have to write this. I'm going to go through it pretty quick. Um, this is the difference of cubes. It's a special factoring pattern that we learned, and it was written this way. It says if you have a number cubed plus or minus, in this case it's minus, that's why we said difference, then this factor actually can be written as a minus b times a squared plus a times b plus b squared. And in calculus, they expect that you remember this. It doesn't come up often. I just want you to be aware of that. But what is that? How does that factor out then? Well, let's look at this. If I factor this out, what is the a? Well, a is the x. So I'm going to put an x here, here, and here. And then what is the b? Well, a b is a 2. So I'm going to put a 2 here, here, and here. But notice this is 2 squared. So this can be factored as x minus 2 times a squared, which is x squared, plus 2 times x, or 2x, plus b squared, which is 4. So that is the factored expression of x to the third. These blue highlighted pieces are equivalent. They're the exact same thing. So what does that mean? If I want to break this down, oops, and I actually have 2 different pieces. I have an x minus 2 that's a factor, and then I've got an x squared plus 2x plus 4. Now, this is the part that I just want you to be aware of. Everything else I feel like you could do successfully. Notice how this piece inside the parentheses is linear. We're just going to put 1 less than a linear, which is just a constant. But inside this factor is the quadratic. And that quadratic cannot be factored anymore. That's one of the special patterns. When you use the sum or difference of cubes, this part cannot be factored anymore. And then the last step is writing bx plus c. Why is it bx? Because we're 1 degree less than what we have inside the parentheses. And then you could multiply. If we were going to go through this, I would take this blue highlighted piece and multiply all the numerators by it and see what would cancel out. And then we would just go through and do the same steps we've been doing. So I don't think you needed to write this one down. To my knowledge, this is the only time you're going to see this in this class, the difference of cubes in partial fractions. So just making you aware that don't forget things that you've learned in the past do come up. All right, here's what we got for homework tonight. There is on our Google slide, actually, let me show you it here. If you go to week 11, and today's Thursday, so we got the blank notes. This is the homework. So if you click on this link, your task cards are going to show up. It's going to look like this. All right, which you don't really need to read any of this part. I should have snipped it down. I just didn't. But here's the problems we did. Well, notice we already did number 2. We just talked about number 5. I don't recommend doing that one, but you could. If you want to do number 5, you can. Here's number 7 that we did, and we did number 9. All the rest of them are different problems. Now, I will point out the answers are right down here at the bottom of the page. But all I want you to do is pick 5 problems that you think you either are comfortable with or you want to challenge yourself with, but do 5 problems on a separate sheet of paper, and then you're going to show all your work, and then you're going to take a picture and submit that to Schoology. All right? The last thing is I want to show you this because I understand this is tricky. Look at the very bottom part of our week, the Thursday folder. Worked out solutions. So if you click on, All right, well, I'm going to make sure that, oh, there we go. Here is my worked out solutions to all 15 problems. All right, look at this is the problem we just talked about. This is number 5 that we just did. So if you're interested in how that works, go ahead and take a look. Now, why do I do this? If you're just going to straight copy, it's still going to take you time and it's going to be annoying, but you shouldn't. You should try it on your own. And then for every problem, go ahead and look to see, or if you're not sure that you got the right A and B above it or the right factors, check first before you do all the work. All right, so that's why I'm showing you this work, just so you guys can be successful with this and build your confidence. All right, that's all I have. I'm going to be available from 1 to 2 o'clock in my office hours today. Please stop in if you need help. If